So now let's look at the asymmetric interaction and look at a linearized analysis near each of the four fixed points that can exist in the system. So the linearized transformation matrix is obtained by taking the derivative of the right-hand side with respect to a and b. Right-hand side with respect to a will get 3 minus 6a minus 2b. And then we take the derivative with respect to b and it'll get minus 2a. So that's the first row of the matrix. And here, for the second row, we take the right-hand side, first derivative with respect to a, and that gives me 1/2 b. And then I have 1 minus 2b plus 1/2 a. So that is the linearized transformation matrix. And now let's look at each of the fixed points that exist in the system. Again, it's so simple to write the fixed points that I didn't bother enumerating them, but let me now just state what they all are. There's a fixed point clearly at 0, 0, where there's nobody left. And in this case, the transformation matrix is 3, 0, 0, 1. So the eigenvalues are equal to 1 and 3. And this is an unstable point because both eigenvalues are positive. So if I look locally near the fixed point, here is a fixed point at 0, and the flow is away in both directions. There's the fixed point at 1, 0, where only the A species survives. And then the transformation matrix is minus 3, minus 2, 0, 3/2. The eigenvalues at each of these fixed points are 3/2 and minus 3. So this is a saddle point. So again, if I look near that fixed point, there's a fixed point at 1, 0, and this is a saddle point. Because along the x-axis, there will be flow inward and there's flow away when I have any admixture of B. The other single species fixed point, 0, 1, at this point, A is equal to 1, 0, 1/2, minus 1. The eigenvalues are equal to plus or minus 1, so this is also a saddle point. So again, looking locally near that fixed point, the fixed point is at 0, 1, so it's a saddle point. So if I have only B's, I flow towards a fixed point, but any admixture of A's, and I flow away. And finally, I have the coexistence fixed point, which is at 1/4, 9/8. And again, A has been suppressed by B, so it's at a smaller value than 1, whereas B has been enhanced by A, so it's at a larger value than 1. And the linearized transformation matrix is minus 3/4, minus 1/2, 9/16, and 9/8. And here the eigenvalues are equal to 3/16, minus 5, plus or minus I root 7. So the two fixed points are complex, but the real part is negative, and that means that we have a stable spiral. So again, about that fixed point, A and B, so there was a fixed point here, and the flow was in towards the fixed point. So this is the linearized analysis of this asymmetric interaction model.